this is the last part. I want to show you the CODESYS test manager. And again, the question, why should I automate application tests? Before I answer that, I would really recommend to do application tests. I'm sure you are doing that. However, we know that you cannot test too little. You will always find things. But why automating such tests? One answer is quite obvious, because it's no fun to manually test software. We know that in our company because we had to do in the past, and we still do some manual tests when releasing a version. And be sure, we do a lot of these manual tests. For every release of CODESYS, we use about 150,000 test cases. You can imagine that we could not do it without a tool. But for application software, it's perfect to automate tests in case you have long-running projects. Yeah, you develop the project further on over years. So the same tests must be carried out frequently. It's for sure no fun to do the same tests every month again and again. So therefore, continuously providing a basic functionality assures your quality of the software. Again, if software modules are developed and maintained on a long-term basis, it makes, of course, sense to automate that. For that purpose, there are unit tests realized. So units, POUs, that are, for example, used inside libraries should be tested carefully. And therefore, you could realize unit tests, which just do not test the whole application, but just this certain unit, because they are distributed to many different applications and machines you want to use. So how is this integrated again in CODESYS? We switch back to the development system, log out again. And for that purpose, I now finally enable the CODESYS test manager, which we have already seen in the meantime, because I forgot to switch it off after the preparation. And this test manager is at first step administration tool, which shows me test scripts which are available, and a test repository where I can put all these test scripts. Of course, there's a difference between the application, between the project file and the testing, because tests are usually not directly connected to the application. In some cases they are, but you might have tests for any application within the development system. Therefore, there is the possibility to have multiple test repositories. And it might make sense to have a test repository for every special application test and to make a versioning of the test scripts maybe in there. So what are the test scripts? At first steps, there are just step-by-step commands which I could do manually in the development system, but which I can record somehow with this test scripts. And this is what I've done here with this example fridge test. So in my application here, I have a 2-point regulator for a refrigerator control system. So you can imagine there's a temperature, actual temperature inside the refrigerator, and there's a set value which I want to keep somehow, and I have a hysteresis between the actual value might change, and in case it's coming over that value, then the cooling compressor should be switched on, so it's cooling down again into this area where I'm sure that my butter and my meat and fish is not becoming bad. And I can test now this application by means of that test manager. So at first step, what can I do? I can prepare, and for doing so, I can add so-called test cases. So a test case is just a group of test actions, can give it a name. And I've done that already here for the prepare case. And there is a test action, which I called login. And what would it do? It will log in to the controller that is already configured for the communication. So my local soft PC in here. So this is done automatically. I don't need to do that with the button here or tool online login. So this action will do that for me. Then I can have a next test case, for example, with several steps. actions. For example, I check the default set temperature and I say the temperature should be 8 degrees. Now, I have to admit that I did not change for this presentation the degrees from Celsius to Fahrenheit, but I'm sure you will find yourself convenient with this Celsius degrees too. So 8 degrees Celsius is the normal temperature inside a German refrigerator. And typically the temperature will jump around between 8, 9, and 7 degrees Celsius. Okay, by first step, I check whether the set temperature, so the one I've put on my controller, is 8 degrees. Check that. I check whether the actual temperature is below 9 degrees. And in this case, the cooling compressor should be switched off. And in case everything is correct, I can set something. So I can write the variables within that test action. So I take the actual value and set it to 9.1 degrees Celsius, which is over the hysteresis. So this means that the cooling compressor should be switched on, and I want to check that. So I check if this is true, and then do the same thing in the other direction. Set the actual value to 7.2 degrees. Give it a delay because then the cooling compressor should still be working. And within that 10 seconds, it should be reaching that 7 degrees, the lower level of the hysteresis, and switch off then the compressor, which I check, it should be false. Okay, just delete these 2 test cases, which I've added for the presentation here. And then let's try it. Okay, how can I do that? I can just press here this play button, which saves and runs the test script. I'm asked whether this is my computer, if I'm the tester. Yes. So I start it. And you see that immediately there's something magically happening without my interaction. So CODESYS is trying to download and log in. And as soon as the download has been performed and the application is running, I will see that in the status line below. And I will see in my task window of Windows that there is another dialog opened, which is in the background. However, I can open it and see that all these tests are now performed, all these steps. Here we are in the delay part right now. And as soon as I've finished all these steps, I get a result. In this case, everything is green. Test was performed without problems. Everything succeeded, so no problem at all. So in order to show you what happened if I have a problem, I will run the test again. And as soon as I'm in the delay phase, I will change the value for the actual temperature to another value. So here we are. So I check that and give it to 9. T, no matter. So in any case, we see that the cooling compressor didn't manage to go below this 7 degrees in order to switch the cooling off. So I get an error message, and I can now check now the values of cooling compressors are not equal. The expected value is false, but the current value is true. So this is given back as a feedback, and I can even program some test messages inside this result screen here. By the way, the results are stored as so-called reports. Here you see that I've already done some of these or executed some of these test scripts already today, and can recap them and even save them for further purposes. Okay, so this is the easiest way to work with these test scripts, where I realize the test steps by means of a dialog. So it's time to answer some question Does it run tests under CODESYS IDE or on the runtime at the controller level? Now for these first test method where I have this dialogue-oriented tests, it's like I would sit in front of the CODESYS development system and do, for example, changing the values as I did right now. So it's like performed from outside with the development system. We will see in a minute that there are other possibilities too. There's another question. These options of tests, are they only in the professional developer edition? Yes, this is an add-on tool and you need to have that license for that add-on tool. But you will see, if you have that license, you will save so much effort that it's worth to have it. Good, but it's just one way of testing. There are two other ways of testing. One is called IEC unit test. For that purpose, I log out again. And let's open that test script here. So this looks quite similar, but it's quite short, isn't it? There's just one preparation test case, which closes the existing project, loads another project, updates the device, sets the communication to the local PLC. And you see, there are all these options that I can do manually, done automatically by these test actions. And then there's nothing more. There's just one more action saying unit test. I can do that, add IEC unit test. How is that test performed and where's the test code and what is tested? I will show you, but before I do so, I execute that test script. Start it once again. And as we have seen it here in the test case, it will close the old project. It will open another one, set the communication settings, download this application. And yeah, we see here the new code here. We see as well the test progress in here. And there will be something happening. I just want to mention it right now because here we have a very simple project with a PLC or PRG. Oh, and you see there's another one as a backup. Just copied inside here. I will go to this in a minute. Yeah, and everything is run through. Okay. So what was done right now? At first step, this is the original project. Let's look inside. There is no code in the PLC PRG. What was tested? Within the project, there was in the PRU tree test code realized within the IC 61131 object. So it was really programmed within the application itself. But how did the test script know to call these objects and not other ones? Now this is quite simple. So I double click on one of them and you see there are two different possibilities, full implementation and implemented with CAA BM. BM stands for behavior model. Come to that. In both cases, the test script knows due to the fact that there is a special attribute in the declaration part of that object. And I've switched the color here to red, so it's quite obvious to see. So this attribute test tells the test script that this code should be only executed during the execution of the test script and not during the runtime, during the standard operation. So you can now realize objects, function blocks, programs, and additionally, objects which test this object. And you can be sure that by this test attribute, this code is not be used for the commissioning and for the standard operation of the machine. Let's check it a little bit further. There are some more attributes I can set, for example, the test case name, test category, and then we need a certain interface to be implemented during that full implementation. First step, we need execute and abort as Boolean variables, and we need as output busy, done, error, aborted. So these are the must-have inputs and outputs. And then of course we need a testee. What function block should be tested? And this is in this case a library object, which is in the standard library, the counter down, and I have here instantiation of it. And within the code, I just determine that I'm busy, that I predefined some initial values for the instance of that counter down. Then I check the behavior by means of code and determine whether the behavior was as expected or not as expected. And then I set the output values accordingly. So X busy, false, X done, X error, X aborted. And at the end, if everything is correct, X done is true. Or if there was an error, X error is true. So this is what is coming back as the result. So this was the full implementation where I have to care for that variables manually. But there's another implementation based on a so-called behavior model. For those of you who are familiar with object-oriented programming, you might be familiar as well with behavior models, which you can just inherit. So there's a behavior model, e-trick, and perhaps we check that there is a special behavior model library needed for that purpose. And have a look at this. I see a set of these classes. You see there's e-trick, and if I take a look into the documentation, then e-trick serves as a basis for edge-triggered function blocks, or e-trick A serves as a basis for edge-triggered abortable function blocks. And this is exactly what we were using in here. We just extend that behavior. And this means that we do not write all the code manually, but we just inherit code, which we can call with this super operator. And we need some start code for the initialization of the measure of the testing. Then we have a cyclic action where we have the standard checking whether the behavior is correct. And in case we have an aborting, we can put the code inside here. And in case there was an aborting, we can reset the outputs, or even after the test was finished in a small method in here. So coming back to my device tree, where I said that the original PLC PRG was empty. Why was it copied? The whole application was just copied. The answer is quite simple, because in the new PLC PRG right now, there were implicitly calls to this check code performed. They were generated. So I see that these calling were automatically performed by the tool itself, by the test script. And in order to go back to the original version, I just can delete that application, rename that back to application, and that was it. So this is performing unit tests. Yeah, especially for those of you who are familiar with library development, this is the tool you should have and should use. Last but not least, I want to show you the same thing, but not by programming manually these codes, but by doing that by means of a test table. Perhaps I close all editors before I do so. Coming back, same thing here. I prepare and run an IEC unit test. But in this case, that project that will be loaded is not realized by means of manually coded test code, but by generated test code due to I have to stop that test. This was unintentionally. I want to run this one. Abort. Okay, so again, the existing project is closed, a new one is loaded, and the unit test is performed, and then we'll take a look at the test table. You see, wow, there's magical things are happening here. Again, here the test script does a lot of things by generating such code. Okay, I log out. We've seen that the report was good. No, not yet. Okay, now we have the report. Everything is passed and succeeded. So we can have a look at the test table. Again, here there was a backup of the original code. The original PLC PRG was empty, and there was just a test table in here. This test table has now global information. The first step, the name, some description that I may give, and there is a testee I want to test. Now, what is the testee? Again, here, I use a library function from the standard library, and perhaps I insert manual a new test table in order to show you that in a better way. So add test table, yeah, you've seen that. Add object, test table. Then I'm asked for a name and for the testee. So the testee can now be any function block program within the project or within a library. In this case, I've chosen for timer on delay from the standard library, could be another one. And I can scan it and see then, due to the scan, which inputs and outputs does this function block have, and whether I want to take these variables into the table. So I add it. And again, here I get the global information, testee, test name, some further options, and then the tabular editor. So let's go to the other one back again. Here again, we have test cases and we have different test actions, which we now define via the test table. For example, reset sets the reset to true, or counter up sets different values and checks the output whether it's behaving like I expected. And I cannot just have single executions, I can as well have multiple executions. Take something here and say I do that multiple times, or I can do something and wait something for a certain time span, of course, using the syntax that we know from the IC 61131. With this method, I can now build up my test and test whether this is true or false, whether there's a rising or falling edge, or whether we have here a direction, perhaps in another test table where I have the elapsed time. Let's choose just something inside here. I can check whether it's greater, equal, and so on. So I have all the possibilities in order to check that. And out of these test table actions, there will be automatically code generated. So all the code you see here was not manually coded, but it's generated out of this list here. And that's now a very powerful possibility to realize unit tests without programming them. Good. Now I'm at the end of the live demonstration. You have all seen that in the live mode. So I can come to the conclusion finally. So it's already late for me and late for you. Perhaps you are becoming hungry. One question as the conclusion once again, why work with professional tools? I think, at least I hope that you've seen that these tools speed up your work. And these tools help to reduce trouble. They help to reduce trouble, and they pay really off in no time. It's immediately paid off because this money you have to spend, you can avoid so many troubles, so many additional effort that this money is really a good investment. Now, last question, how do you get it? Of course, in the CODESYS store. Just click on CODESYS store, search for Professional Developer Edition, and then you get the license for it. However, this is only the license to use it. The tools themselves, as I've already showed that, are manually installed. Yeah, so they are installed. So the profiler is one tool, static analysis is one tool or one package, and therefore you can as well search for them as well in the store and install them from here. You cannot purchase them because you have to purchase the complete subscription for it, but you can download and install them. There's even a 30-day trial license for free, so you can work with that too. These $600 are a 1-year subscription. Okay, there's another question. Must tests be run from within the IDE or can they be scripted? Let's say we have a continuous integration setup using Jenkins or GitLab, so I can run tests automatically when I check in new code. Is there a way to have the CI tool run the CODESYS test? Answer is yes, it's possible. You can check them from outside. We use them too, tools like Jenkins. We can, you can set up that yourself, but we can as well consult you how to do so. We have a special consulting department. So just get in contact with Chris and the other colleagues. They will tell you how to proceed. Okay, so you can try for free, make your own experience and find out whether these tools are worth for you. In any case, I really claim that there's a high benefit for these high-tech tools, and they're designed to boost your daily work, and they should really do so.